what I've done in this, there's a lot going on here. This is heavy. I've made a population up here in cells B3 through B8. It's a population of 6 random numbers. If you press the F9 button, you'll get 6 new ones. And if you press it again, you'll get 6 new ones, you'll get 6 new ones. I mean, it's kind of like what you just did with the warm-up, in that you're randomizing a population. The only condition I put on this population was that every one of those numbers is between 0 and 1. That's the only condition. It doesn't matter. I mean, I just picked any population. That was the easiest one for me to think of. So it's a ran between 0 to 1. No big deal. Okay. What I've then done under that is I've given you a whole bunch of, not statistics. Do you remember what the measures of populations are called? Starts with a P, like population. Thank you, Emily. Say a little bit louder, please. Oh, yes. It's a parameter. The parameter is what we want to know about. We really want to know what Donald Trump's approval rating. Maybe you don't want to know. But somebody does want to know what... She's shaking her head over there. No, she didn't. What's going to be fun is when somebody watches this video in 12 years and goes, who? Trump. So, but somebody wants to know that, right? And somebody wants to know, for example, if I make that medicine that I was talking about before that gets rid of that condition in the deck of cards, it used to be 50-50, 50%. Somebody is also going to want to know, is it lower than that now? And if it's lower than that, what is it? Is it 38%? Is it 32%? Is it 16%? Those are all parameters, right? They're in the population that we're studying. These are 9 parameters from that population. Some of them you may have heard of before, some of them you may have not heard of. Let's go through them one by one to make sure you understand. The mu is the mean. That's the average value of those 6 numbers. The median is the middle, if you put them in order. Let's see, if there's 6 of them, which means it's a little bit goofy, right? If there's 6 of them, you got to go between the 2 middle ones. So let's see, in order, it's 32, 52, 58, 83. So halfway between 58 and 83 is 0.71. Okay. Little sigma, that's the population standard deviation. That's the remember what a standard deviation is from 243? Remember what the interpretation of a standard deviation is? How much have we lost over the summer? Probably all of it. That's okay. When you think standard deviation, what do you think?
How far away it is from the average.
Holy crap!
It just came back in my head.
It just came back. It's how far away you are from the average. On average.
Bert and Ernie.
No, Bert and Ernie. It's Bert and Ernie from 243. Yeah. You got it, girl. So on average, we're 0.21 units away from the average of 0.67. This is sigma squared. I don't think I ever even mentioned this in 243. I'm not sure if Donna talked about it. It's called the variance. She may have mentioned it. She's a lot more traditional than I am in that way, which is awesome. It's called the variance. It's the square of the standard deviation. More on that in a second, but it's not. Don't memorize that. It's just worth knowing because it's got a name for temporarily. This is the percentage of the data that's greater than a half. I needed to pick a percentage to compare it to, so I picked a half since it was between 0 and 1. So you would think that half of it should be bigger than a half, and on average it will be. Right now, looks like 5/6 of it is. Yes. 1, 2, 3, 4, 5. 5 out of 6 is 83%. Average deviation. I'm going to use the same definition Katie gave me for standard deviation to describe average deviation, because essentially it's the same thing. It's how far away on average you are from the average, just calculated a different way. And notice it's very close. 0.21, 0.2. Very, very close. Mode. Remember what the mode is? Oh. Say that again.
Most frequently.
Yes, most frequently occurring. What's fun about this data set that I have right here is it has a mode. A lot of times it doesn't. Like right then. There's only 6 numbers between 0 and 1. There's a lot of numbers between 0 and 1. The fact that that one had a mode was actually pretty fun. So usually it doesn't. The range, just how far apart they are from the bottom to the top. And the skew. Remember skew? Remember skew from 240? What does skew mean in statistics? When we talk about data that is skewed, do you remember?
Whether it moves from one side to the other, but it's based upon... I can't remember that.
That's okay. I love what you said. What you said is enough. Whether the data leans to one side or the other. On the warm-up you just did, was that data distribution skewed? No, it was almost perfectly symmetrical. It probably was just the smidgen, I'm making up words, the tiniest bit skewed because it wasn't perfectly symmetrical. But my God, we all called it Bell, and I did too. This data, if you actually plotted it, this one, you can actually tell by looking at it. Look, 0.29, 0.09, 0.21, 0.2. Those are all below a half, yes? 0.56 and 0.5. One's at a half, and one is just slightly above. That data is skewed. It's leaning to the left side, which makes it by definition, I believe, right skewed, which is a strange thing, but it leans left. That's why the skew is positive in this case. Sometimes skew will be negative, so you can find a negative skew. There's a negative skew. That means there's more on the right side than the left side. So skew is just a way of saying, is it leaning to one side or the other? The closer it is to 0, the less skewed it is. So I picked 9 parameters that this data has available to it. That's all. Some of those you probably have heard of before. Actually, you've heard of them all. Whether or not you studied them in any great detail is to be determined.